Hello friends, welcome to my channel Academic Mate Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon to get notified whenever I upload a new video. An important happy news for all the CBSE Class 12 students is that Academic Meet Easy PC channel has come up with a Google Classroom and the Telegram channel. So the link for Telegram and Google Classroom is given in the description box. So I would request all of you all to join our classroom in order to access your materials, and any queries will be cleared in telegram group. And also the telegram link is also given in the description box and in the channel page, so I want all of you all to join the class. So now I'm going to give you all the real life example so that you will be able to grasp the concept very quickly. So first let us see for relations and then let us see for functions. So first for relation, just consider there are some people. Okay, so in class 10. Okay, so class 10, let this be set A. Set A, there are some boys. Let that be B1, B2, B3, etc. Okay, and in set B, I have class 11 students. Okay, there are some boys, say just B1, B2, B3, etc. Okay, so I'm just going to relate these two sets. So as we all have already learned what is relation, right? So what is a relation? Relation means we are relating two given sets. Say A and B are the two given sets and we are relating to some common properties. So that is what relation, right? So here also I'm just going to take these two sets, class 10 boys and class 11 boys. So now what I'm going to do is that I'm going to say that a boy in set A is a brother of a boy in set B. Okay, what am I saying? A boy in set A is a brother of a boy in set B. Okay, this is a relation. Relation means nothing but it is a literal meaning relationship. Okay, so it is related to something or the other. So consider this example for your understanding. So set A and set B is there. I'm saying that a boy in set A is a brother of a boy in set B. Say I'm saying that B1 is a brother of B1. Okay, this is one relationship. So for these two sets, what is a relationship? Brothers relationship, right? So this is a common property and I can say that anyone in this class has a brother of set B because we don't know their names or any details is given. So I can say anyone in set A is a brother of anyone in set B. Okay, so this is what relation means. We are relating two given sets with a common property. That is what relations. So let this be example 1 and I'm going to give you all example 2. Now just consider a teacher is preparing, okay? A teacher is preparing her mark record. Okay, and she's splitting the two sets as set A as student's name and set B as their marks obtained. So just a 10 marks test she is keeping. So set A is considered as their names, say A, B, C, D, E, Okay, don't confuse with these variables since I need not to mention any names, so only I'm just mentioning the variables A, B, C, D, and the marks obtained is 1, 2 up to 10. Okay, so now she is just putting into a set and she is trying to relate these two. So if I say that A has obtained 10 marks. So she will be mapping this to mapping A to 10 marks. Okay, and B also to 10 marks and C to 2 marks. D to some other mark. Okay, so what is the relationship between A and B? So A is nothing but the names of the student and B is the marks they obtained. So what is the relation? A student and their marks. This is what the relation between these two sets. So this way we will be doing our problems also in this chapter. So first let us complete the concept of relations, then let's move on to functions. So already I have done a video with the introduction part for the chapter relations and functions. I'm not going deep into the introduction part. Instead, I'm just giving you all a quick recap. So if you have not watched that video, please do watch it. I will attach the link for that video in the description box. So now let us move on with the quick recap of the relations concept. So first let us see the definition for relation. So a relation is nothing but a relation R from a set A to set B is a subset of Cartesian product of A cross B obtained by describing a relationship between the first element X and the second element Y of the ordered pairs in A cross B. As I said, the example, I'm just relating my set A to set B under common procedure or common rule. Okay, that is what they are saying. See, describing the relationship between them. Okay, so there is some relation between those two sets, so I'm just mapping those two. Okay, so now I've given this example. So see here, I will say that A is mapped to 1 and A can also be mapped to 2, and you all know the rules also, right? So the next topic is types of relation. So now we have learned about reflexive relation, symmetric relation, and transitive relation. So now let me give you all an example. So reflexive means what is the condition? A comma A should belong to R. Yes, so in a given relation, A comma A should belong to R for reflexive. Okay, and for symmetric, what is the condition? A comma B should belong to R and B comma A should belong to R. This is what the relation, right? Next, for transitive. Transitive relation. What is the condition? A comma B should belong to R. B comma C should belong to R and A comma C should belong to R. This is what the condition for transitive. And if all these three conditions get satisfied in a particular problem, what is it called? The relation. What is it called? Equivalence relation. Equivalence relation. Okay, so if any one of the condition is not getting satisfied, then we will not say it as equivalence relation. If all these three conditions get satisfied in a particular problem, then we say that it as equivalence relation. And there is also one more thing called equivalence class. Equivalence class, right? So we have a sum based on it. So you all know what is equivalence class. So once more, let us see it in the problem. So here we go with the 1 mark question, that is very short answer type. This will be just choose a best answer or a one word answer. So you will be able to do it. So now let us move on with the questions. So question 1 says that let T be the set of all triangles in the Euclidean plane and let a relation R on T be defined as A related to B. A or B means what? A related to B. If it is in such a way, A slash R B means A is not related to B. You have to know the difference, okay? So if T be defined as A related to B, if A is congruent to B for every A comma B belonging to T. Then R is option A reflexive but not transitive, option B transitive but not symmetric, C equivalence, D none of these. So these type of questions is mostly expected. So now let us once more read this. See, they have given that T means set of triangles. Triangles in Euclidean plane, okay, and R is a relation saying that A is related to B. That is what the only thing. So they have asked whether it is reflexive, transitive, or symmetric, or none of these, okay. So first let us see that for reflexive, what is the condition? A comma A, okay. So I can say that A is related to A. Yes, so A is related to A, that is this one triangle, the same triangle is related to itself, okay. And for symmetric, A comma B, okay, I'm taking A comma B, I'm saying that A is related to B. Then also I can say that B is also related to A. Yes, so I'm taking two triangles, say A and B. I'm saying that this triangle is related to triangle B. So also I can say that triangle B is related to A. Okay, in such a way I will be throwing for transitive also. Transitive, what is the condition? A comma B should belong to R. And I'm saying the same triangles, okay. So triangle A is related to B, and one more triangle I'm taking it as C. So I'm saying that B comma C also belong to R. I'm taking one more triangle. So this B triangle is related to C triangle, and also I can say that triangle A is related to triangle C. So A comma C also belongs to R. Then all these three conditions get satisfied. So what is it called then? It is called an equivalence relation. So I can take this option C. Question 2. If a relation R on the set 1, 2, 3 be defined by R equals 1, 2, then R is option A reflexive, option B transitive, option C symmetric, option D none of these. So you all might think only one relation is given, that to 1, 2. So if it is reflexive, we need A comma A. It's not there. Fine. For transitive, we need A comma B, B comma C, and A comma C, right? For symmetric, we need A comma B and B comma A. When nothing is there, so automatically our mind will choose none of these, right? But that's not right. The option is option B, transitive. Why? Because I'm saying that for reflexive, I need a condition A comma A, which is not there. So reflexive, that's not the right option. For symmetric, I need A comma B and B comma A. Is it there? 1 comma 2 is there, but 2 comma 1 is not there. So my symmetric also is not the correct option. Whereas if I just see A comma B and B comma C and A comma C is transitive, I will say that it is transitive because, see, just consider that it should not be always the same way, like one, for example, I'm saying 1 comma 2, 2 comma 3 and 1 comma 3. If it is in such a way that we say it is transitive, no, not at all. Also we will say that 1 comma 2 is transitive, because just consider 1 comma 2 and 1 comma 2 again. I'm saying that this is my A and this is my B, and in the next condition, for this condition, I'm saying that this is B and this is C. Okay, so what is my A here? 1. What is my C here? 2. So 1 comma 2 is there. So 1 comma 2 is there, 1 comma 2 is there, 1 comma 2 is there. Only once if we write, that's enough for relation. So that's what I'm saying, transitive. So most of us make mistake in this question, thinking that if I have a comma b, b comma c, and a comma c, different numbers only, I can say this as transitive. No, not at all. You can say even this as a transitive. So even one element is there, you can say it as transitive. Okay, hope this will be clear for you all now. Question 3, let A equals to set of 1, comma 2, comma 3. Then number of relations containing 1, comma 2 and 1, comma 3 which are reflexive and symmetric but not transitive is dash. That is option A 1, option B 2, option C 3 and option D 4. So now what is the question that they have asked? They are saying that a relation contains some elements with the relation 1 comma 2 and 1 comma 3. So they are saying that this relation is reflexive and symmetric but it is not transitive. Okay, so how many number of relations should be there in order to get this condition satisfied? Okay, so now I'm saying that a relation is already there. So if I just have 2 comma 1, this condition will get satisfied because already they have said it is reflexive, right? So reflexive means what? That relation contains 1 comma 1, 2 comma 2 and 3 comma 3. Yes, reflexive is already given. So 1 comma 1, 2 comma 2 and 3 comma 3 is already present in the relation. And also they have given added to it, they have given two relations, that is 1 comma 3 and 1 comma 2. So if I add one more element or two more element, I will get a symmetric relation. So what is the condition for symmetric? It is A comma B and B comma A, right? So if I just add 2 comma 1 or 3 comma 1, this condition will get satisfied. Okay, satisfied. So the answer is option A. So question 4, let R be the Question 4, let R be the equivalence relation in the set A, set of 0, 1, 2, 3, 4, 5, given by the relation R equals A comma B, such that 2 divides A minus B, right? Equivalence class of 0. Okay, they have given a set A equals, so solution, so A equals set of 1, 2, 3, 4, 5, that's it. And relation, what they are saying, A minus B divides 2. It means what? If we subtract A from B, then it is giving a integer value. So first I'm taking, since they have asked only equivalence class of 0, I'm just taking with 0. Okay, so 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4 and 0 comma 5. Okay, so if I just take this, R equals 0 minus 1 by 2, which is minus 1 by 2, it is not an integer. So therefore I will just cancel this one. So if I add or subtract with 0 minus 2 by 2, it gives me an integer value, right? It can be either 0 comma 2 or 2 comma 0. So this will get satisfied. So the odd numbers are getting rejected and the even numbers can be ticked. And also we can have 0 comma 0, right? We forgot that. So 0 comma 0 also can be there. So therefore I will say that the equivalence class of 0 is set of 0, 2 and 4. That's it. This is the required answer. If you just write this, you will get 1 full mark. Now it's time to test your knowledge. So this question number 5 will be just to test you. So I want you all to work out and just comment your answers in the comment box. Okay, so question 5, let A equal set of 1 comma 2 comma 3, the number of equivalence relations containing 1 comma 2 is. So you are going to answer this question. Okay, so I'm waiting for your answers. Please do comment in the comment box. If you have any doubts, mention it in the comment box.